Hello and welcome to part one of two of a series of videos on how to add vectors. And in this part we'll talk about what vectors are and, more importantly, why do we care at all. So I'll start off with a couple of questions. First, you're looking at a top-down view of a box and two people are pushing it across the floor. One person is pushing it with a force of 3 newtons. The other person is pushing it with a force of 4 newtons. So how much total force, or net force, is being applied to the box? Well, what do you think? If you guessed 7 newtons, you are correct. They are both pushing in exactly the same direction, so the two forces will simply add together. Now note that how I've depicted these forces as arrows, so you know which direction they're pointing in, and the lengths represent how big the forces are. So the 4 Newton force should be a little bigger than the 3 Newton force. Pretty intuitive. All right, let's do another question. Suppose we have the same two people pushing the box, except this time they're pushing in opposite directions. One person is pushing 4 newtons this way, the other person 3 newtons that way. So what is the total force acting on the box, or the net force? And if you guessed 1 newton, you are correct, because the forces kind of counterbalance each other. And so if they were even pushing with the same force, the box would have no net force and it would not go anywhere. So yeah, this is pretty straightforward. If the forces are pointing the same direction, you add them. In opposite directions, you subtract them. Easy peasy, right? Well, let's do a third question. Now suppose the forces are at right angles. One person is pushing 4 newtons to the right. The other person is pushing 3 newtons straight up. What is the total force, or net force, now? And this is not so easy. We can't just add the two forces. It can't just be 7, because it'd be 7 if they were pointing in the same direction. But they're not. They're not in the same direction, so we can't just add them. But we also just can't subtract them either. So it's got to be something in between, something less than 7 newtons, but greater than 1 newton. So that's our quandary here. Now, in order to figure this out, we need to think about what are called vectors. Now, a vector is simply any quantity with a magnitude, i.e., how big, and a direction. So basically, a force would have, say 4 newtons. That's the magnitude, and the direction would be to the right. There are a lot of quantities in physics that we encounter that are vectors: velocity, acceleration, force, displacement, and there are plenty of others that you will learn about as you go. And the beauty of learning about vectors is that once you learn how to manipulate vectors, it applies to all of these different kinds of quantities. And it's universally applicable. So the same problem with 4 newtons and 3 newtons is this problem here with a boat that's trying to cross a river, with the current going up at 3 meters per second, and the speed is 4 meters per second to the right. If we can add force vectors, we can add velocity vectors the same exact way. So we need to learn how to add. That's right. When you learned addition in elementary school, you learned that 3 plus 4 is 7. We need to finish the job, and we will do that in part 2 of this video. But now you've seen why we need to learn about vectors and why they are important.